Hey guys, coming at you again with another video. This one is going to be very similar to the problem we did today on the quiz. I'm hoping that just one more resource can kind of help you guys get past the fear you have of these types of problems. They're really not that bad. It's all stuff that you are fully capable of doing. It's just combining a bunch of concepts. So let's just kind of break this down one step at a time. We have 10.91 grams of sodium carbonate being added to 184.9 milliliters of 0.552 molar. Remember that capital N is molar, which is molarity, which is moles per liter. So this literally means we have 0.552 moles of aluminum nitrate per 1 liter of solution. So you have an idea what that means. It then wants us to write the balanced chemical equation. So let's go from there. We have sodium carbonate, okay, which is going to be aqueous once it dissolves, being added to aluminum nitrate, which is aqueous because it's told us a solution. That's going to form sodium nitrate, which is aqueous according to our solubility rules, and the one that's important, aluminum carbonate, which is not aqueous. He is our solid, so he is our precipitant. Okay, so remember our precipitant is going to be our solid product that is being formed. So we use our solubility rules, figure out who the solid is, bam, there's our precipitant. Now, we're then asked to figure out how many grams of precipitant can be formed. Well, if we go through and break down what we know, we have 10.91 grams of sodium carbonate. We have 184.9 milliliters of a 0.552 molar solution, and we're being asked to find the mass of the precipitant. So because we have these two starting values, we know we're dealing with a limiting reactant problem. So to figure out how many grams of the precipitant are going to be formed, we need to take both of our reactants to the product and kind of figure out how much product can be made from both of them. Then we can compare them. So we have our 10.91 grams of sodium carbonate. Now, we are in grams. To switch substances, remember we need to be in moles. So our first step is going to be to get into moles. Well, how do we take grams to moles? Molar mass, okay? Which for sodium carbonate is 105.99. If you want to calculate it out for yourself, you are welcome to. I might suggest, if you want to, pausing the video and solving these out for yourself and then comparing what you did to what I did, just as a thought, okay? From here, we have to do our mole ratio, and we forgot to balance. So let's pause 2 seconds from this part of the problem and come back up here. We always have to balance. I'm sorry I forgot to do that. That's my fault. There we go, and then a 1 over there. So now when we come back down here, we can do our mole ratio, which is 3 moles of sodium carbonate to our precipitant, 1 mole of aluminum carbonate. All right, and last step is to get into mass because we're being asked for grams. So for every 1 mole of aluminum carbonate, we have a mole 233.99 grams aluminum carbonate. Okay, so I always set them up and I go back and plug everything into the calculator at the same time. So I'm going to go back and actually solve that out in a minute. Now, my next one is this weird one, which is molarity. There's 2 different ways to do this. I'm going to walk you through both ways. The first way is to get our moles using our algebra, which is just recognizing that molarity is moles over liters and plugging in what we know, which we know we have a molarity of 0.52 molar is equal to X moles, which is what we're trying to find, over our volume, which needs to be in liters, so 0.1849 liters. So when we do this math, we end up with 0.552 times 0.1849, and we end up with the mole value being 0.102 moles. Now, this is moles of the creature in our solution, the species in our solution, which is the aluminum nitrate. So this is AlNO3. Okay, well, once I'm in moles, it's kind of like I just skipped this step. Okay, or well, I did that step here, technically. It's just a little bit different because I didn't start in grams, I started in volume. And instead of using my molar mass ratio, I'm using my molarity ratio. Okay, so from here, I can go straight into my mole ratio. So for every 2 moles of aluminum nitrate, I end up with 1 mole of aluminum carbonate. And then from there, I would go into grams again. So for 1 mole aluminum carbonate, we have a molar mass of 233.99 grams aluminum carbonate. Okay. Now, let me back up and do this set for you. So you can do it algebraically. That works beautifully. I have a lot of students who like to do that, and that's perfectly fine. This is how my brain likes to function too. I like algebra. I work well in algebra. But there is another way we can do this. Okay, and I'm going to erase some of my train tracks and come back and do it. I can start with my given being my volume. Okay, so I can go 184.9 milliliters, or I can go ahead and convert that into liters one way or the other. I'm going to go ahead and start with it in liters. So 0.1849 liters of my aluminum nitrate solution. Okay, well from there, I can now use my molarity as my ratio. Okay, because it is a ratio. It's how many moles there are in 1 liter. So for every 1 liter of my aluminum nitrate solution, I have a ratio of 0.552 moles of my aluminum nitrate. And now, connect my train tracks, convert my moles of aluminum nitrate into moles of aluminum carbonate, and continue on. So there's a second way we can go through and work out these problems. Okay, so for time's sake, I'm going to pause real quick and calculate these, and then I'll write the answers down for you guys. All right, so I just did the calculations off screen. What I'm getting is, for the first one, for the sodium carbonate, it can form 8.03 grams of the aluminum carbonate. And for the aluminum nitrate, it can form 11.94 grams of the aluminum carbonate. So, once we have these two values, we have to recognize that the amount of precipitant that can be formed is going to actually be our smallest amount, because once 8.03 grams of aluminum carbonate has been formed, all of my sodium carbonate is gone, because that's the max amount of aluminum carbonate that can be made from this amount of sodium carbonate. So there's no more of this. It's gone. It's used up. Well, once it's used up, there's no way for the reaction to proceed forward. So there's no way 11.94 grams is going to be able to be made. The only amount that can be made is 8.03. It's, again, kind of going back to our cooking analogy. I can have enough flour to make 500 cookies, but if I only have enough eggs to make 100 cookies, I'm only going to be able to make 100 cookies. So kind of the same idea. So with that in mind, who's our limiting reactant? Well, our reactant is going to be on our left side of our reaction, so it is the species that made the smallest amount. So sodium carbonate. And some of you guys like to tell me, well, 8.03 grams of aluminum carbonate is my limiting reactant. Aluminum carbonate is not a reactant, so it cannot be the limiting reactant. The limiting reactant is the species that makes the smallest value of product, so sodium carbonate. Okay, let's keep going. Let's get off that tirade for a second. Whoops. Smartboard's being spazzy, go figure. If we have 7.42 grams of the precipitant being collected, what is our percent yield? Well, percent yield, remember, is actual over theoretical. Theoretical is what your teacher is going to give you, so 7.42 is what I gave you as being collected, over our actual, which is what we calculated up here, so 8.03 times 100. Okay, and we get a percent of 92.4%, so 3 sig figs because of everything going over here. Now, one of the problems you guys have had the biggest issue with is how much excess reactant is left over. You all freak out about this. Let's just break down this question. Let's go back to that whole flour analogy. If I have enough flour to make 500 cookies and I only have enough eggs to make 100 cookies, I'm only making 100 cookies. Well, how much flour is left over? That's all it's asking, and in a very simple form. We know all the sodium carbonate's being used, but how much of the aluminum is going to be left over? Now this one's actually going to be a little bit more complicated than the one on your quiz, because the one on your quiz, the limiting reactant was already in grams. Our excess reactants was in grams. Our limiting reactant was our solution. In this case, our grams is our limiting reaction and our excess is actually in solution. So we're going to need to figure out how many grams we had in solution originally, good practice of using molarity, and we're going to have to figure out how many of those grams was actually used to begin with. So let's start with calculating how many was used. We know we had 10.91 grams of our sodium carbonate that was used up all the way. That's our limiting reaction, reactant. That's by definition what we know. From there, we can actually use two values, by the way. We can start with the 10.91 or we can start with the 8.03. Because both of these values are definitive values, meaning all of this was used up and all of this was formed, versus we never actually made 11.94 and not all of the 184.9 liters was used, or milliliters was used. So we're only going to use the numbers we know. So we're going to either use the limiting reactant or the amount of products that's produced. I always use my limiting reactant value because I know it has no rounding errors. So it's kind of a clean slate. There's no rounding errors. There's no mathematical errors. It's a given number. I can run with it and do my calculations accordingly. So I'm going to start there. Now, instead of taking sodium carbonate to aluminum carbonate like we did here, I'm going to take it to my aluminum nitrate because he's my excess. So let's kind of work that out. Okay, so we have our aluminum carbonate. If we remember correctly, our molar mass of aluminum carbonate is 105.9. This one's kind of irritating because the problem's all the way up at the top, but that's okay. All right, and that's per 1 mole of sodium carbonate, because remember, molar mass is always per 1 mole. From there, we have our mole ratio, which is 2 to 3. So we have 3 sodium carbonates for 2 aluminum nitrates. And then from there, we're going to convert that into grams, which we don't have the molar mass of aluminum nitrate. We're going to need to calculate it. So let's do that real quick. Okay, and our molar mass is 213.01 grams of aluminum nitrate per 1 mole. All right, I am running out of time to continue this problem. So what I'm going to do is I'm actually going to pause here and I'm going to make a second short video to finish up E and F. Unfortunately, the program I use only lets me make 15 minutes worth of video, and I need probably about 18 minutes. So we'll call it there for right this second, and then I'll finish up for you guys. Thanks. Give me a minute.